really model an entire city if you wanted to, and you can make it as complicated as you want. I mean, we're gonna keep it simple, just so you get introduced to the program and what it does. So the first thing you're gonna do is you open WaterCAD, you're just gonna click New, and we're gonna lay out our system. So we're gonna click this layout icon. And the first thing we're gonna do is we need to set up the point of connection at Gemini Boulevard. And we're gonna model that as a reservoir. Okay? So we're gonna set an elevation for that reservoir, and that's gonna provide the pressure for the system. So we're gonna do that. And then the next thing we're gonna do is we're gonna have what we call junction nodes. And I'm just gonna put in 3 junction nodes. And those junction nodes can represent a fire hydrant, or they can represent a grouping of lots, okay? But the total length of this would be the total length of your potable water main within your particular development, okay? So the first thing we're gonna do is we're gonna define the reservoir. And what's critical about the reservoir is this physical elevation. So that physical elevation is that total dynamic head that we calculated from 45 pounds per square inch. And I don't know what that is, but I'm just gonna say it's 200 feet, okay? It's close to that, but you can calculate what that actually is. So that's 200 feet. The other thing I have to do is in WaterCAD, and we're not gonna get into this, but what I could do is I could set up a model that has a number of different zones, so that if I wanted to just isolate a zone, I could do an analysis for that and then do an analysis for everything. We're just gonna have one zone, but we have to still set up a zone. So under zone, if I click here, I'm gonna say edit zones. I'm gonna click new, and I'm gonna create zone 1, okay? So now I can select zone 1. So for all of my nodes, I'm gonna select zone 1, okay? So for the reservoir, that's pretty much all I need. Elevation and zone, okay? So the next thing I wanna do is I want to set up each of these junction nodes. So if I select junction node, okay? I'm gonna put in a few things. The first is the physical elevation of that particular node. So I wanna know what that is. I'm gonna put in whatever my demands are. And then I'm also, what was I gonna say? Sorry, I lost my train of thought. Elevation, and zone, sorry. So elevation, I'm just gonna say it's elevation 100. Zone is 1. And then under demand, where it says demand collection, I'm gonna click that, click these 3 dots, and I'm gonna put in whatever that demand is, okay? So let's say this first one is a fire hydrant. So I'm gonna put in 500 gallons per minute, okay? So I'm gonna pick another junction node. So if I pick junction node 2, I'm gonna do the same thing. Elevation, whatever the elevation is of that particular node, I'm gonna say it's 98. The zone is again zone 1. And then the demand, I'm gonna come up here. Now I'm gonna say the demand is a whopping 10 gallons a minute. So that 10 gallons a minute represents a grouping of lots. Okay? So I can do the same thing for the 3rd junction node. So again, elevation of that particular node, zone, whatever zone it is, and then whatever the demand is. Yeah.
Is there a maximum number of lots that you would assign to one junction?
There's not. I mean, I would just say, for simplicity's sake, don't assume all your lots are in one node. Like I would separate them out, like maybe assume 5, 6, 7, 8 lots per node, something like that. Just so you can create a model, practice doing it. But yeah, good question. Okay, the last thing we're gonna do is we're gonna define our pipes. And for the pipes, again, we're just gonna need to provide simple information. It's a pressurized system, right? So we're using Hazen-Williams. So what we need to be able to do is we need to be able to identify, number one, the zone. So I'm gonna click zone 1. The diameter, and what's our minimum diameter?
8 inches.
8 inches, right? I'm gonna pick PVC pipe, but for the purposes of what I'm gonna just, you can, PVC. I'm gonna assume my Hazen-Williams, and then user defined length, I'm gonna click that to true, and then I'm gonna put the length of that particular pipe. So in this case, I'm gonna put 200 feet, okay? So I'm gonna do the same thing for each of my pipes. So once I have all that information in, I'm ready to run it. So, look at that, ready to go. So this is an example, set up the same way, it's in reverse, but I have a reservoir here, it has a certain total dynamic head, and I've got nodes with demands. So to run it, I'm just gonna click compute. It's gonna run. And then like all these programs, there's a gazillion reports, but I'm gonna pick the junction report. And what that junction report's gonna do, it's gonna tell me what the hydraulic grade is or dynamic, total dynamic head is, but it also is gonna give me the pressure. Okay, so in this case, for the total dynamic head I used, I have a minimum pressure of 49 PSI, right? So this thing is fine. So that means that it works. So I had a fire hydrant in here at 500 gallons a minute, and then the demands. So that's it. So what you're gonna do is you wanna make sure that you provide that minimum pressure of 20 pounds per square inch. And if you don't, you have to increase your pipe size. Okay? Any questions on AutoCAD? Yeah.
You said the minimum for a fire hydrant was 45 PSI?
No.
Oh,
Your point of connection is 45 PSI.
right.
The minimum pressure within your system is 20 PSI.
Okay. Got it.
So you can imagine, I mean, we're doing a simple case, but just think if you're designing, an entire subdivision or development, I mean, you're gonna have a lot of other pieces and parts. Well, we're not modeling or valves and things like that where you would have losses. So you would have losses for those valves, so those things would typically be modeled so that you include that. So your pressure isn't just as clean as we have it, you would have losses along the way. Yeah?
Is there a pressure that's too high?
Yeah, there is, but I think